Okay, welcome to Research Methods. This is our fourth week, and today we're going to be talking about how to select your research participants. Remember, all of you have to do a research project. You're all hopefully going to design a survey because it's the easiest thing to do, and you're going to have to you have to think about where your participants are going to come from, and we're going to talk about that today and the strategies involved. And we're going to talk about a bunch of fancy methods for selecting research participants. And then what's going to happen in the end, you're just going to do the easiest one, which I'll explain what that is. So let's get started. So we're going to talk about samples and population, sample size, probability sampling methods, and then non-probability sampling methods. Those are the ones you guys are probably going to use, the non-probability sample one, the easy ones. Okay, so there's a bunch of stuff listed there. Let's just get started talking about samples and population. And you probably heard a little bit about this already, maybe from Psych 101. I know I talked about samples. I introduced that concept. And we're going to talk about how important that is for research. Okay, so an introduction to sampling. So what is a sample, first of all? You must select a sample of participants. The sample is the basically small group of people who are going to be in your study, who are going to participate in your study. So let's say the 100 participants or so that complete your survey, the 50 participants that do your experiment, the 40 participants you observe or something like that, that would be your sample. Okay. Now remember, survey is what I expect you guys to do, the simplest thing. And I believe I require, if you look at the syllabus, I require that you collect data, basically that you sample at least 50 participants. You could do more, but you should not do less. Even 50 for a survey is really small and you should really do more than that. But I'm being nice and saying you only have to do 50. But that's a sample. It's the group of people who participate in your study, okay? Samples tend to be similar to the populations they were taken from. We'll define populations in a moment, but the sample must have some things in common with the population, with the larger group of people who you want to speak to, that you want to generalize to. I'll mention that in a moment as well. I always get ahead of myself. Because the researcher wants to ensure that their samples are good representations of the populations they want to study. You cannot study everybody, okay? Let's say you can't study all alcoholics, but you can ask, you can give a survey to maybe 100 of them, and hopefully that survey tells you something about what alcoholics are like in general. That is the goal, but we can't study everyone, so we must select a sample. Let's keep going. Let's relate samples to populations, although I already did that, but we're gonna talk about this a little bit more. So the selection of research participants is a critical issue in research planning. It's very important, in other words, that you select your sample carefully, okay? The outcome of the study may depend on the method used to select participants. It says may depend. I can tell you from experience, the sample determines everything. Yes, the outcome of the study definitely depends on the sample. You can find one result if you select a certain group of people. If you select another group of people, you can find a totally different result. So the sample is important. And in order to make sure you're doing things right, you need to make sure that your sample is a good sample, that it represents the population it was taken from. Now, what is a population? I mentioned that already, but here's a definition for you. The population is the large group of interest from which the researcher selects the sample. So the population is the broader group of people where the sample is taken from. Now you might think the population, that would be everybody in the world, right? That's the population. Well, no, not that huge group of people necessarily. Your study is not about everyone. And you might say, oh, well, maybe the people in the US. No, it's probably not about everyone in the US. But let's say you're interested in people who are depressed, and you do a survey about, symptoms of depression and how common they are, and in people who are depressed, what percentage of people, for instance, have, sleep problems or have lost their appetite, you know, all sorts of things you can ask about. The population would be basically other depressed people. Okay, so the population is the group of people of interest. And it doesn't necessarily, it's not necessarily everyone that exists. Okay, so don't get confused with that. And the sample is the small set of individuals who participate in the study. They're a small set of people that actually are taken from that population. You can't study everyone in that population. You can't study all depressed people. So it's a small number of people who are going to participate, and that is your sample. The goal of the research is for you to be able to generalize from the sample to the larger population. You want to be able to say that this group of people here, what I found out about them tells me about what's going on out there. That is what you want to do, and that's called generalization. You want to be able to generalize. From a small group of people, you want to be able to generalize and say that that's happening out there in the population. Let's keep going. And here's a visual for you guys to further illustrate the relationship between a population and a sample. So you can see at the top there, that first oval there at the top, it says the population of individuals of interest, okay? So it might be, you know, people who are depressed or people who are alcoholics, schizophrenics, whoever you're interested in, right? That's the population. It's not everybody, okay? It's just the particular group of people who have something in common that you're interested in, okay? And then the arrow going this way on the right, downward, it says the sample is taken from the population. Out of the population, you select a group of people, because you can't study everyone. And then the sample, the specific set of people who participate in the study, the actual study is done on those people, done with those people, okay? And then you use the results that you collected from those people to generalize to the population. So you have the arrow going back up the other way and basically, and then pointing at the population again, because the sample says something about population. That is the logic, and that's a visual supposed to make that easier for you guys to understand. I think it's simple enough already, and the visual might actually even make it more complicated. But the point is, you select the sample from the population, and then you do the study with the sample, and then the results that you obtain with that sample are then used to say something about the population. That's called generalization. And hopefully you've heard about that before. It's not a difficult concept. Here it is again, more words. So you want a representative sample, okay? You want a sample that represents the population. A sample with the same, a representative sample is a sample with the same characteristics as the population, okay? Because generalization is done more easily if your sample looks like the population, has things in common with the population. So generalizing the results from a given sample to the population depend on depend on the sample's representativeness. So the extent at which you can say that these depressed individuals that I studied here tell me something about depressed individuals out there in general, that whether you can say that depends on how well the people you studied actually are like those other people out there who you didn't study, the broader group of people. The researcher must determine how well the accessible population represents the target population. There's some other terms there, other definitions there we'll talk about in a moment. But the point is that you need a good sample that represents the population. Let me give you an example of how things can go wrong. About something that's a little bit where larger numbers of participants are used. Let's say you want to determine, for instance, the likelihood that President Trump is going to get elected. Okay, so you do a survey, okay, and you ask people, you know, simple question, just one question: are you voting for Trump? Yes or no? A survey could actually be one question. Now, for your project, it's not going to be one question, okay? No, not at all, okay? You need to have more than that, a dozen, 15, or something like that. Something a bit more substantial to do. But let's say you just have this one question, and you want to know how people are likely to answer this question. And say, are you voting for Donald Trump, you know, in the next election? If your sample is representative, if your sample really does represent, you know, the people in the US, the people who are basically likely to vote, or the people who are registered to vote, the people who can vote, if your sample really represents that population, then you should have a good approximation and say, well, according to my survey, you know, about, 51% of people plan to vote for Trump. So Trump is going to get reelected. According to my survey, I'm predicting that Trump is going to get reelected. Or if it's 47% who say they're going to vote for Trump, then the survey suggests that Trump will lose the election. See, you can say something about the other people out there who you didn't study from your sample. But if your sample isn't representative, let's say you only ask Republicans to participate in your survey, and the survey says that 80% of people plan to vote for Donald Trump, right? Well, you can't really generalize that, okay? The whole country isn't Republican, okay? They're about half and half, Republican and Democrat. So that sample would basically overestimate Trump's chances of winning. Or if you only ask Democrats, right? The sample might say that 80% of people plan to vote for someone else other than Donald Trump. And that would mean that Donald Trump is going to lose miserably, okay? But then that wouldn't be a good representative sample as well, because, you have about a mix of 50-50. You have moderates in there too, but sometimes they lean one way or the other. But a sample needs to be representative for you to say that your study actually says something about what's happening out there. Okay, and that's the point. But you must determine how well the accessible population represents the target population. So let me introduce a few more terms so you understand. Okay, so there is also something known as the accessible population. So you have your sample there in the middle. Those are the people who are selected to participate in the study. They are basically they are taken from what's called the accessible population. It's a portion of the population. Turns out that not everyone in the population can be a part of the study. So the accessible population is the portion of the population basically that consists of individuals who are accessible. I'll give you an example. Let's say again you want to do a survey about Donald Trump, whether he's going to win or not. You have to basically select a sample of people who are likely to vote or people who are registered voters. But it turns out that not everyone is accessible. There are some people who do not have phones, who do not have internet, and who are going to be really hard to reach. And by the way, those people are likely to be Trump voters, just so you know. They're not accessible, so they cannot be in your study, okay? So your sample is taken from the accessible population, okay? Those are the people who are accessible, people who you can reach. And then the accessible population is taken from the target population, the population of interest, okay? But not everyone in that population is accessible. So we can start from the outside, actually. You have the population, the whole bunch of people, let's say, who can vote. That's the target population, or you can just call it the population. And then from there, there's a group of people who you can actually reach. That's the accessible population. And then you select your sample from the accessible population. Okay, those are the people who are actually going to participate in your study. And that's something we have to think about. In the last election in 2016, Trump was expected to lose, and he ended up winning. What happened? There was a lot of things that actually happened. There's something known as the Electoral College, which obviously it complicates things and doesn't make it easy to predict, because it's not, it's not that, when the majority of people vote for a certain candidate, it's not always the case that that person wins. There are some cases where that person actually loses and somebody else won who had actually a smaller percentage of the population. That was the case with Trump, but he won because of the Electoral College. But there's also something else that happened. I think the support for Trump was underestimated because the accessible population were the group of people who they were able to reach, and who were then, they were able to then take a group of people from that accessible population to participate in the survey. Well, it turns out there's a bunch of people who are not accessible, who live in the middle of nowhere, who don't have internet, maybe don't have phone or whatever it is, and those people came out and voted for Trump. They're way out there in the boonies and stuff like that. They don't want to be bothered. They live in rural places. A lot of those people probably were not in the sample because they were not part of the accessible population. So to some extent, the support for Donald Trump was underestimated. Hillary was supposed to win like really easily by a landslide, and she lost. Now, she did win the majority vote, but the election doesn't, you don't elect someone here in this country through a majority. It's through the Electoral College. You have to win individual states, and those states have certain votes or certain electoral votes that they represent. And if you get above a certain number, I think it's 270, I think, then you win. And Donald Trump did not win the majority of the votes. he actually won less. So in that case, I guess the sampling was a little bit accurate, but he won the Electoral College. But either way, it was predicting that Hillary was going to win really easily, and she lost. And people were shocked and crying, and people were expecting history to be made, the first woman president. They were all very disappointed, right? Donald Trump ruined all of that. But it's because of the accessible population. There's a bunch of Trump voters. There's a bunch of people who don't normally vote who came out and voted for Trump. He was a different candidate. We'll see what happens in this next election. They're predicting he's going to lose again. I wouldn't count him out. Okay, I mean, it's just the way it is with Trump. He always finds a way, you know, to win. You know, we'll see what happens. Okay, now let's talk about threats to a representative sample. So yes, you want a representative sample, a sample that adequately represents the population, so that you can make predictions. Basically, that's what this is about. So that you can say that your survey says something about what's happening out there. Based on what I found in my survey, I predict that this is what's happening out there, okay? So threats to a representative sample. Bias is a major threat, and I kind of mentioned this already, a bias, right? You may have what's called a biased sample, okay? A biased sample has characteristics that are noticeably different from the population. So, you know, some individuals in the sample may be older, faster, smarter, whatever it is. And that can represent a biased sample. If, let's say, your survey for, let's say, who's going to vote, you know, are people going to vote for Trump, yes or no? If your survey is composed mostly of older participants, that would be a biased sample. That would benefit Trump. That would be skewed in the direction of voting for Donald Trump. Or if, you know, or if they're younger, that would be skewed against Donald Trump. If they're college educated, that's against Donald Trump. If they're less, you know, so there's characteristics that can bias the sample, okay? You want a representative sample, okay? And well, what's a representative sample when it comes to the US population? I mean, there's a lot of variety out there. Older, young people, right? College educated, non-college educated, rich, middle class, poor, men, women, gay, straight. You know, you have to get a representative sample. And how do you do that? It's a bit hard, but we'll talk about that, okay? Selection bias, also called sampling bias, is when participants or subjects are selected in a manner that increases the probability of obtaining a biased sample. So when you select your participants in a way that basically increases the chances that you're going to get a sample that's not representative. So let's say with your survey about Donald Trump, you only go to rural places, okay? Or you only take your sample from so-called red states that lean more Republican. That would be, you know, you are using selection bias, basically. You're being biased in the way you are obtaining your sample, and that's going to lead to a biased sample. It comes in many forms, of course, you know, but that's selection bias. Sometimes we're not aware that our sample is biased. Now, there is something also known as sample size. You need to be concerned about your sample size, okay? The researcher's goal is to select a sample that's representative of the population. And the law of large numbers says that a large sample will probably be more representative than a small sample. If you want to do your survey about Trump and you only have like 10 people in your survey, that's probably not good. Those 10 people are likely to not all, but they may not be representative. It might be that a large portion of them lean one way or another way. It's not a good sample. Now, if you have hundreds or even thousands of participants in your sample, chances are, right, that because you have so many, they're more likely to be representative. It's more likely that you have old people, young people in there, gay, straight, you know, rich, middle class, poor, you know, and it's likely to be more representative. That's what the law of large numbers says. Okay, think of it this way. Let's say you flip a coin. Now there's, with a coin, there's supposed to be a 50% chance of getting heads, 50% chance of getting tails. But if you flip the coin, let's say 10 times, so it's like having only 10 people in your sample. You flip the coin 10 times, it's possible that you might get 8 heads and 2 tails. It's very possible that what the coin tells you isn't really what actually happens. It's supposed to be close to 50-50. But because you have a small number, right? Small number that you flip, you only flip the coin a small number of times, or you only have a small number of participants, it's very likely that the sample is biased and isn't really going to tell you what's really happening. A sample size, just to give you some guidance here, a sample size of 25 to 30 individuals for each group of or treatment condition is a good target. Okay, so here's the thing. So having 25 or 30 individuals per group, okay, if you're doing like an experiment per group, per treatment condition, okay, is a good idea. Like if you're doing an experiment and you plan to get half your participants drunk and then half of them are gonna remain sober and you wanna see how aggressive they are, let's say if you're doing an experiment, not a survey, an experiment, you should have about 25 to 30 individuals per group. So if you have those that are gonna get drunk, those that are not gonna get drunk, then you need, well, if you're gonna have 25 for each group, you need 50, okay? When you do a survey, you just need, you know, a larger number is better, okay? Now here's a visual for you guys to show you how this works. And I hope this doesn't confuse you guys. But the average distance between a sample mean and a population mean. So you can see on the left there, the scale that is vertical, scale from 0 to 10, says the average distance between a sample mean and the population mean. That means, okay, so what is the difference between what's really happening out there in the population and what you found? What is the difference? Obviously, you want the results that you found from your sample to be as close to what is actually happening in the population. So the smaller the number, the better. And what this is telling you here is that when you have very few participants, let's say you only have 1 participant or 4 participants, you see when you right here the scale that's horizontal here, number of scores in the sample. When you have a small number of participants, when you start at the beginning there, only 1 participant, the distance is close to 10. The difference is close to 10, and you have only 4. The difference is close to 5. So basically, as you get more participants, the distance or the average. The difference in the average between what the population and the sample decreases, meaning that basically the differences in what you found versus what's happening out there decreases. And what you want is for your sample basically to say exactly what's happening out there. So you can see it approaches 0 with more participants. It never quite goes to 0. There's always a small difference. But the point is, the more participants you have, the more likely it is that what you found, let's say you found an average of something, whatever it is, or the percentage of people who are going to vote for Donald Trump or something like that, whatever you found is likely to be very close to what's happening in the population. Let's say you found that, 51% of people plan to vote for Donald Trump. And in the population, if you were to be able to test everybody, it might be that 50% plan to vote for him. So it's close, right? Because you had a good number of participants in your study. I can tell you that when it comes to, doing a political poll, those surveys that try to predict, like things about politics and stuff like that, they usually do those with like 1,000 participants. They used to need like 10,000 participants or 20,000 participants to have an accurate result. But now they can do a good poll with as little as 1,000 participants. I've seen polls, where they just use maybe like 100 or a couple of hundred. How can they get away with that? Well, the better they get at sampling, the more carefully they select the sample, the more accurate it's going to be. And if you select your sample very carefully, then you don't need large amounts, huge samples to determine what's happening in the population. Yeah, the more the better usually. So let's talk about these, more about sampling then. Sampling basics. What kind of sampling can you do? Okay, and I get the feeling that, I'm probably going too slow, but we'll be okay. We just might have a bunch of time for discussion. We'll see. Sampling basics. So what kind of sampling can you do? There's 2 basic categories when it comes to sampling. Okay, there's probability sampling and non-probability sampling. Okay, probability sampling is a few more rules that you need to follow. So for probability sampling, you have to know the exact size of the population. Okay. So if you wanted to know, let's say, if you were doing probability sampling for a survey on predicting whether Donald Trump is going to win the election, you have to know exactly how many people are out there that can vote. So you have to know exactly how many eligible voters there are. And that is something that, is actually, they can probably know. They can probably find out the exact number of people who are register to vote who are eligible to vote, okay? Each individual also in the population must have a specified probability of selection. Each individual usually has to have the same chances of being selected. So if there's like 1 million people in the population, then each of them has a 1 in a million chance of being in the survey, let's say, or being in the sample. The selection process must be unbiased. It has to be random. Okay, it can't be that you just pick and choose whoever you want based on a certain state or based on a certain age. It has to be unbiased, has to be random, and we'll talk about how you do that. Okay, that's probability sampling. Non-probability sampling is where the odds of selecting a particular individual are unknown. With non-probability sampling, you don't know how many people there are in the population. We don't know how many depressed people there are, for instance. You don't know the chances of selecting one versus another, okay? And you often don't know when you select people whether it's biased or not. Actually, most likely it probably is biased, okay? But we'll talk about that and how it works. So let's talk about probability sampling methods first. These are a little bit more complicated than non-probability sampling, but it's not too bad. So probability sampling methods, one type of that, one form of that is called simple random sampling. With simple random sampling, you select participants from a list containing the total population. So let's say we know we have in the computer somewhere in a database, we have every single person who is eligible to vote. Okay, so we have a list of everyone in the population. And from that, we take a sample of people that are going to be in our survey. And we just want to know if Donald Trump is going to win the election. Okay, if people are going to vote for him, yes or no. So we have the list. Okay, we know exactly who's in the population. And we have a way to contact them, right? Let's assume that, right? And there is equality. Each individual has an equal chance of being selected. So if there's 1 million people, again, then each person has a 1 in a million chance of being selected. Okay? And you also need independence. The choice of one individual does not influence or bias the probability of choosing another. So if you select one individual, that person has a 1 in a million chance of being selected. You select a second individual, that person also has a 1 in a million chance of being selected, or almost a 1 in a million chance. So you need to know exactly how many participants there are. Each has an equal chance of being selected, and selecting one does not influence the chances of selecting another. That's simple random sampling. Now, there's two things you can do with simple random sampling. So two principal methods, okay? So you can do sampling with replacement and sampling without replacement, okay? And this is easy. Sampling with replacement just means that when you take an individual from the sample, okay, and then you collect data from that individual, okay? So that person is recorded as a sample member. You then return that person to the population, okay? So if you have 1 million people who are in the population and then one person is selected, that person's in the sample, okay? Then what happens is that you still include that person in the population. So the next person that is selected still has a 1 in a million chance of being selected. It's possible, though highly unlikely, that you may select the same person twice. Because with sampling with replacement, you take the person from the population and you study that person, and then that person is still in the list. So that person may still be selected again. Although it's highly unlikely when you have 1 million people in the population or more. It's highly unlikely. But that's sampling with replacement. Now there's also sampling without replacement. Sampling without replacement is when you basically select an individual from the population to be in your sample. You do not then include that person in the list anymore. So that person is crossed off the list, cannot be selected a second time. There's no chance of selecting the person. The problem with sampling with replacement is that it changes the odds a little bit for the second person. So the first person had a 1 in a million chance of being selected. And then that person is then crossed off the list. So the second person that is selected has a 1 in 999,999 chance of being selected. So actually, I said that wrong. Okay, so the first person, okay, has a 1 in a million chance of being selected. And then you select that person, you cross them off the list. So the second person has a 999,999 chance to 1 of being selected. So the chance of selecting the first person are 1 in a million, and the chance of selecting the second person are a little bit less than 1 in a million. But you know what? The difference is so small that it's still considered practically equivalent. So it's still considered random sampling or simple random sampling. Okay. Now, there are concerns with simple random sampling. One problem is that chance determines each selection. It's possible, although unlikely, to still obtain a distorted sample. You can still get a biased sample. Like an example would be a coin toss. It's supposed to be 50-50, but you can toss that coin 100 times and you can get, 60 heads and 40 tails, which is biased, okay? It's not supposed to be like that. It's supposed to be pretty close to 50-50. But like with a sample, when you have a population that has 1 million people, and each person has a 1 in a million chance of being selected, at least for the first one. The second one, it's, basically has a 999, okay, has a smaller chance of being selected, okay? Then you can still obtain a biased sample. Just by chance, you might select participants that are relatively older on average, just like you got more heads just by chance when you flip the coin. Or you can also select by participants who are relatively younger, who are maybe relatively more educated, or whatever it is. You can still get a biased sample. It's not guaranteed to give you basically an unbiased sample, a representative sample. It's more likely to give you that, but it can still happen. Just like with a coin toss, you can toss it a bunch of times, and it can still give you odds that are not exactly 50-50. So we need additional restrictions on random sampling to avoid this non-representative sample. Okay, we need to avoid getting a biased sample, so we can place additional restrictions. Okay, and what are those restrictions? Well, we can do what's called systematic sampling. Systematic sampling is a type of random sampling. With systematic sampling, basically what you do is you select every nth participant. N could stand for any number, so you can select every 9th participant, every 5th participant from the list. Okay, so every nth participant is selected from a list containing the total population. You can select every 5th, every 7th, every 9th, every 13th, or something like that. You select a random starting point. Okay, so we're going to start, let's say, let's just choose a random a number randomly. Okay, 13. Okay, so every 13th participant. Okay, so we'll start number 13, and then we'll count 13, and that's the next person. Another 13, that's the third person, and we do it that way. It violates the principle of independence. Every person doesn't have an equal chance. I mean, selecting one person, if you start at number 13, then that basically affects, the extent to which someone else can be selected, the chances of somebody else being selected, because it's going to be every 13th, okay? So if you're not every 13th, you don't have a chance of being selected. So it violates the principle of independence, okay? Where you start and, what number you start affects the chances of selecting the every additional person. But it does ensure a high degree of representativeness. Okay, you select every 13th person. Every 13th person is going to be in the sample. Chances are you're going to get a variety of people in that sample. So it increases the odds of obtaining a non-biased sample, but it violates some of the rules of, probability sampling. You can also do what's called stratified random sampling. With stratified random sampling, you basically break up your population into subgroups, and these subgroups are called strata. So strata is just a fancy word for groups, okay, or for subgroups. Okay, you break up the population to different groups, and what you do is, you have equal numbers for each of the groups. Okay, so you have so many of this group, so many of that group. You break it up into different groups. Okay. Before I move on, let me just show you an image here so you understand what we mean by that. So let's say you're interested in studying income, let's say family income. You're interested in studying that. So what you can do is you can you can break up families into 4 different groups. Families with incomes above 250,000, families with incomes above 100 but below 250, families with income above 40 but below 100, and families with income below 40,000. Okay, you break up the population to those 4 different groups, 4 different strata, and you select an equal number from each. That is stratified sampling. Okay, so that guarantees that each group will have an adequate representation. Hey, you have poor people in there, right? Or you have your people who are making at the bottom there, making less than 40,000, family income below that, you're probably poor, at least in California. If your family makes less than 40,000, and you have your, you have your upper class, above 250,000, and then you have, of course, your upper middle class and probably your middle class there, and it basically, it guarantees that you're going to have representation, that all of those groups are going to have a voice, let's say, in the study or a voice in the survey. Or let's say you were, you're interested in something that has to do with ethnicity. Or you can call it, let's call it race just to make it simpler. I know it's not the same thing, but you can have your black people, your white people, Latinos, Asians, people who are mixed, and they're all selected in equal numbers. Okay, that's stratified random sampling. The overall sample though, although you do have representation of all groups have a voice, the overall sample is not representative. Okay, so let's look at the image here. Let me show you. Okay, so everyone's included, okay? That's good. You have representation, but you don't have representation that is equal to the population, okay? You can get a biased sample. So for instance, you have 20 of each group. So families with incomes above 250,000, you have 20 families that are in that category, and you also have 20 for the others. Well, guess what? Families with incomes above 250,000 do not make up 25% of the population. If you select 20 from each, that means that you're going to have a total of 80, and 20 are going to be from families with incomes above 250,000. So they're going to make up 25% of the sample. Families with incomes above 250,000 are not 25% of the population. No way. It's probably closer to maybe 5%, maybe 10%. I'm not really sure, but it is a small number. It's below 10%. Okay. I do remember something like, and this changes from year to year. I remember something like if you have a family with an income above $500,000, let's say, then you're like in the top 1% or something like that. Okay. So this might be in the top 5%, maybe top 10%, somewhere around there. And it's not representative of the population. They're making up 25% of the sample, but maybe they're only 5% of the population. So they have a too much representation in the survey, in the study. So in that way, you have a biased sample, but at least everyone's represented, okay? Now, there's a way you can fix that. You can fix that by doing something called proportionate stratified sampling. With proportionate stratified sampling, again, the population is divided into strata. The population is divided into groups, like income or something like that. But here, the number of participants for each stratum, for each group, is selected randomly. And you make sure the proportions in the sample correspond to the proportions in the population. So let me explain this a little bit further. So you break up your population into different groups. However, you don't only do that, you make sure that each group is represented based on proportion. So if, let's say, if families with incomes above 250,000 only make up 5% of the population, well, then they only make up 5% of the sample. So let's say you had 100 families participating, or 100 individuals, let's say, or whatever it is, just to make it simpler, okay? Those that with incomes above 250,000, only 5%, so therefore only five out of 100, there will only be 5 of those individuals out of 100. So if you have 100, let's say families or 100 individuals who participate in the study, those with incomes above 250,000, if they only make up 5%, then there's only going to be 5 of them. Okay, because 5 is 5% of 100. Okay, so it has to be proportionate. This is proportionate stratified sampling. That guarantees the sample will be perfectly representative of the population. So you have representation, but it is also proportionate. It's perfectly representative. So some strata may have limited representation. That's a problem, right? Families with income above 250,000 they will be represented, but they only make up a small percentage of the population. So therefore, there's only a small number of them in the sample. That's the way you need to have it if you want proportionate stratified sampling. So they don't make a large percentage of the population, so therefore they shouldn't have a large voice. The thing is that in the kind of society that we do live in, the rich actually have an outsized voice. They have a much larger voice than people who are poor or middle class. So it doesn't work that way in the real world. But if you're doing a survey, you have to follow some rules, right? If you want it to be representative. But of course, you know, in the real world, especially politics, the rich, even though they're a small percentage, are going to have a lot of influence on what happens. Now, if you were to just ask people, right, and do a survey and make it representative, the rich wouldn't have much of a voice at all because they make up a small percentage of the population. Anyway, that's a digression there. You can also do something called cluster sampling. Cluster sampling is when you basically select clusters. Clusters are also groups, but they're groups that already exist. You don't create them, okay? Clusters, pre-existing groups, are randomly selected from a list of clusters, basically, within the population. Those clusters have to meet certain criteria, okay? So let's say you're interested in children of a certain age, okay? So you select, you know, basically certain classes in an elementary school, okay? Those are clusters. Those classes already exist. So it's a very quick and easy way to obtain a large, relatively random sample. You select classes, and everyone in the class is going to be in the study. So you can select 10 classes of third graders, let's say from a local school. It wouldn't be from a local school, it'd be more like from a district, because you probably don't have 10 third grade classes in an elementary school. They're usually not that large. You might have 3 or 5 classes of third graders, but let's say from the whole district, okay? There's several elementary schools in the district, and you select basically 10 classes from that district, 10 third grade classes. Anybody in that class is gonna be selected, okay? Anybody in the class is going to be in the study. Those are clusters. They're groups that already exist, okay? So you can get a large number of people to be in the study very easily. Hey, this class, and that class was selected. So therefore, you know, those people in the class are going to be in the study. The problem is that the scores may not be independent. The people you select may not be independent, okay? Because if you're in the class, you're in the study. If you're not in the class, you're not in the study. It's not really independent. It depends on the cluster. It depends on the class, okay? If your class is selected, you have a 100% chance of being in the study. If your class is not selected, there's a 0% chance of being in the study. And selections are not usually random or independent. The chances of obtaining one class or the other, well, not the chances of obtaining the cluster, but the chances of obtaining one person, one student versus another, they're not independent, like I explained, right? It depends on whether you're in the class or not. So there are some problems. It violates some of the rules of probability sampling, but it's still called probability sampling. You can use what's called a combined strategy sampling, right? Where you have 2 or more strategies are combined to select participants. You can use 2 or more strategies. Like for instance, you do simple random sampling, but you combine that with, let's say, with systematic sampling. You do simple random sampling, but you select every 9th participant or something like that. You can combine, or you can use simple random sampling and combine, and then make it proportionate, okay? To make sure that you have, you know, basically the people you select are represented in the sample according to the number, the percentage they make up in the population, okay? You can combine strategies is the point here, okay? So this optimizes or increases the chances that a sample is representative of a widely dispersed or broad-based population. It increases the chances of getting a representative sample. Examples of applications, a wide market survey or political polls. When they do a political poll, a wide market survey, they usually study a lot of participants, and they'll combine methods, you know. Though, like I said, they might do simple random sampling, but they also select every, you know, 10th participant or something like that. Or simple random sampling within a certain city or within a certain state, or, you know, because they want to make sure they get an equal number of red states and blue states and things like that. Yeah, they combine strategies. That's all that means. Now, there's also non-probability sampling methods. Non-probability sampling methods are easier to understand, okay? With non-probability sampling, they basically violate the rules of probability sampling. And the easiest form of this is called convenience sampling. Convenience sampling is basically where you just, you get your participants your participants, basically, they're going to be whoever's willing to participate, whoever's available or willing. And this is what you guys are going to do. You're going to design a survey, probably, most likely, hopefully. And who's going to be in your survey? You're going to ask your friends, your family members, people you know, basically, or your classmates. And by the way, you shouldn't go out there physically contacting them, okay? Send out your survey via email. Create it in Google Forms, okay? And it makes it easier to create the survey when you use Google Forms. And then you can email it to a bunch of people. You can share a link, or you can put a bunch of email addresses in there, send it out to a bunch of people. So your sample is just going to be whoever's willing to participate, whoever's available, whoever's in the class that gets the email, or whoever's in your family or your list of friends that gets the email, whoever's willing. Okay, it's a very easy method for attaining a sample, very easy way to get a group of participants, right? But the sample is probably biased. Guess what? Your friends, your classmates, they're probably not like the population that you're interested in. And what I find is, you know what? If you're, if you're Latino, your survey tends to be mostly Latinos. Okay, that's who tends to be in your survey. If you're white, there's more white people in your survey. If you're black, there's more black people. That's what I tend to find. Okay, if you actually want to make it, proportionate, then you have to do some other things to make it proportionate. But if you just use convenient sampling, it's like whoever you know, whoever you contact, whoever's willing, that's who gets to participate. Okay, it's a very weak form of sampling. The researcher makes no attempt to know how many people there are in the population. We don't know how many people are depressed, or how many people smoke weed or are alcoholics. We make no attempt to find out how many there are, and we probably cannot. No attempt to use a random process in selection. There's no attempt, to use simple random sampling or some of those other things that we talked about. You do none of that. So I know we talked about a lot of things, and you have to know them for the homework on the exam. But when it comes to how you're going to do it, you're going to do it the easiest way. And here's the thing about sampling that is a little bit disconcerting, or a little bit maybe shocking is not the word, but a little bit weird, I guess you could say. All those bunch of studies that you read about out there that are psychology related, just about all of them, the samples were obtained with convenient sampling. So you have these researchers, these professors doing research, let's say at USC, UCLA, places like that, and the participants are, well, whoever's willing to participate in the study. And they're usually 101 students, Psych 101 students, because there's a whole bunch of them. And there's a rule to the class that they have to participate in like 6 or maybe 5 hours of research. And that means they just have to go sign up for a study and participate. Okay, and maybe fill out the survey, be in the experiment or something. And they usually use convenient sampling for those studies. Almost all of those studies that you read about, they use convenient sampling. And probably because of that, they're probably biased. They're probably not representative. So there's a lot of weaknesses. But that's what they do. They don't try to use all those other methods for the most part. Some do, but usually not. Okay. Now there's a way you can make convenient sampling a bit better. You can at least use something called quota sampling, in which you use convenient sampling. You still select whoever's willing to participate, but you use a few techniques of probability sampling. Okay. So in other words, you can make, one example would be is that you can make your convenient sample proportionate. So whoever's willing, but let's say you want your sample to be representative. Okay, so let's say you want like half the people in your survey, you want half to be female and half to be male, which is a good thing. Okay, so you want them both to have an equal voice in the survey. Okay, so you use convenient sample. You ask people, hey, you want to be in my survey, or you send them an email. And when you get enough females that participate, they'll say, all right, no more females. Now I only need males, or I need to get more males to get up to 50, let's say. So you select 50 of each, let's say, for a total of 100, and you'll have 50% males, 50% females. Still convenient sampling, but you only get a certain number of each, let's say, of each sex. Or if you're interested in, things that have to do, let's say, with, let's say sexual orientation, then you get an equal number of, let's say, of people who are heterosexual, homosexual, bisexual, whatever it is, however you break up the groups, okay? Or you can also make the sample proportionate. Let's say you have let's say you're interested in college students, community college students, let's say. And it turns out, let's say that in the community college, only 30% are male and about another 70% are female. That means that your sample has to be 30% male and 70% female. So if there's only 50 individuals in your sample, then only 15 of them are going to be males and only 45% females. To make it simpler, let's say there's 100 participants for your study. If you want it to be proportionate, that means that only 30 of them are going to be male and 70 are going to be female. That's what it represents the population, let's say, of the community college. So you're interested in the average community college student, let's say. Okay, and believe it or not, in the community college at AVC, a greater percentage are females. I forget the exact numbers, but female students make up close to 60% of the college population at AVC, and males make up close to 40%. So there's a lot more females going to college than males. And by the way, that is something that we see like almost everywhere. There's more females going to college than males now, and they make up a greater percentage of the community college population across community colleges, even at the four-year level. And they're starting to do so also as well, even at the graduate level. Now, not in all majors, of course. I mean, like engineering, math, there's mostly males, like 90, 80% males in those majors. But in general, even in graduate school or undergrad, it's mostly females who are getting now those AA degrees, those BA degrees, and even those advanced degrees, master's degrees and PhDs. Now more females are getting them than males because there's more of them going to college. So if this trend continues, we're going to have more educated people who are female than males. It used to be the reverse in the past, but for some reason, more females are going to college now and less males. Probably because it's easier for a male to get a good paying job without a college degree. It's a lot harder for a female, believe it or not, to get a good paying job without a college degree. There's less opportunities for females. Females need usually more education. It's the kind of world that we live in, and that trend is probably going to continue. And you know, those of you who are female, you know, and you're going to have a college degree, you probably would want to marry someone who has a college degree, but there's a good chance that you might end up with someone who doesn't have a college degree, because in general, we're going to have in the future, or in the near future, who knows how, you know, how it is right now, but we're going to have more females with degrees than males. And if this trend continues in the future, it will be a lot harder to find a male with a college degree for those college educated females, because you usually want to marry someone who's like yourself. Here's just a summary of the sampling methods, and I just talked about them, so I'm not going to go over that, but there's some tables here that you can look at on your own if you want to want a quick summary of each, because we talked about a lot of things and maybe you're confused about what the difference is. But there it is. We are now done. So let me stop this recording.